This video is about graphing two variable inequalities. And what we're going to focus on here is how do we shade or graph inequalities of lines and inequalities of absolute values. Okay, so when we are graphing a linear inequality, we're going to sketch the graph, but the first thing we have to make sure of is the line dashed or solid, or is the absolute value dashed or solid? It's going to be dashed if it's a less than or a greater than. It's going to be solid if it's a less than or equal to or a greater than or equal to. And the difference is when it's a solid line, it means any point that lies on that line or on that absolute value would also be included as a solution to that graph. The second thing that we're going to have to do is shade. Now, there are generally two different techniques for how you shade either a linear graph or an absolute value graph. One, a lot of you guys probably learned prior, which is called using a test point. I'm going to show you another technique which is known as half plane shading, okay? Or I like to use the concept of Y's are big or Y's are little in order to graph these, okay? So let's jump right in here. The first thing I notice is the first graph they want me to do is the graph of a linear inequality. It's a line. I need to solve this for y. So the first thing I'm going to do is rewrite it as 3y is greater than or equal to negative 2x plus 12. And then I'm going to divide everything by 3, and I get y is greater than or equal to negative 2/3 x plus 4. This is what I am trying to graph. The first thing I have to be able to do is write the equation the inequality into a form that is graphable. Now I'm going to sketch a coordinate plane. I apologize if my lines get a little shaky here. I'm going to graph the y-intercept. 1, 2, 3, 4. And the slope negative 2/3 tells me how to move from that point. I'm going to come down 2 and 1, 2, 3, 4 to the right. So down 2, 4 to the right would put it about there. And in order to graph a line, I need 2 points. I'm now ready to draw my line. I look back and the inequality tells me that it's a greater than or equal to. So that means that my line is going to be solid. All right? So the only thing that is left, because it is an inequality, is now I have to decide which side of the line to shade. This is known as half plane shading. Okay? Now, on the y-axis, I know that y's are big up here and little down here. All right? If I look at the way that the inequality is written in this equation, this is saying y's are greater than. I'm going to substitute big in for greater than. So this says y's are big. On which side of the line are the y's big? And hopefully you can recognize it would be on this side. There's my half plane that I would then shade. Okay, let's try another one. Say, give me this inequality here. It's linear. I need to solve for y. So the first thing I have is negative y is greater than or equal to 1x minus 5. Subtracted 5 from both sides. But now I have to divide everything by negative 1. Remember, when you divide by a negative, that flips the inequality sign. This now would give me negative 1x plus 5. And this is the inequality that I'm going to try to graph. I'm going to sketch it. Sketch the coordinate plane. I have a y-intercept of 1, 2, 3, 4, 5. And the slope says from there, go down 1, 1 to the right. That's enough information to graph my line. Is the line solid or dashed? Well, the inequality tells me that story. This inequality, because there's part of an equal sign in it, tells me that the line is solid. So I sketch my line like that. I now have to decide, are the y's big or the y is little. Remember, this side would be big, this side would be little. if you look at the inequality says y's are less than. Instead of less than, I'm going to replace less than with little. Y's are little. That tells me shade this side of the line and all this area underneath the line. And what that means is any location that is in that shaded region, if I plug that point back in for x and y, I get a true inequality statement. What if it's an absolute value? Well, I know absolute value by sketching the vertex and then moving right, left, up, or down based off of the vertex. Stretching or compressing based off of the vertex. So the first thing I want to do is rewrite this as y is greater than absolute of x plus 2. Move that 7 over so it's plus 7. That's telling me this has a vertex at negative 2, 7. There's no number in front, no negative in front, no a value as you're going to learn it to be called. So we know it's not stretched, compressed, or flipped. All right? I go to my graph now. Here's my coordinate plane. I have a point, the vertex, at negative 2, 7. 1, 2, 3, 4, 5, 6, 7. And right there is my vertex. Now, because it is not stretched, compressed, or flipped, I know the parent tells me to go 1 to the right and 1 up, and to the left 1 and 1 up. And that gives me the outline for my graph. Okay? Now, for this particular graph, notice, go back to the inequality. It's a greater than. That means that this line, or this absolute value graph, should be dashed. And the reason why it should be dashed is points that are on that actual graph are not part of the solution to the inequality. Last thing, y's are big, y's are little. Now, would the y's, notice the inequality says y's are big. Would they be big inside the V or outside the V? Well, big is up high, right? So we're talking about locations inside the V. All right, let's try this next one here. All right, I'm going to rewrite it as y is less than or equal to the absolute of 3x minus 4. All right, now this one's going to be a little bit unique because there's a 3 inside. So when you get something like that, you know what? It's not a bad idea to go back and use a t-chart. Now, I believe that the vertex is going to be at 0 something. So let's see what happens here. If I plug a 0 in, I get an output of negative 4. What happens if I plug a 1 in? At 1, I have 3. Absolute of 3 is 3. Minus 4. 3 minus 4 gives me an output of negative 1. Well, let's try the other side of 0. Let's plug in negative 1. Absolute value of 3 times negative 1 would be the absolute value of negative 3. Absolute value of negative 3 is 3. 3 minus 4 is negative 1. Notice what happens. The y's are repeating as the x's were the same distance on either side. That's telling me 0, 4 is my vertex. Or sorry, 0, negative 4 is my vertex. I'm going to sketch this. The vertex is at 0, negative 4. I know if I go 1 to the right, I'm all the way up here at negative 1. If I go 1 to the left, I'm all the way up here at negative 1. And there is a pattern for me to follow. I look at the inequality. The inequality has an equal sign in it. So I know this graph is going to look something like this. Okay? Now I need to decide, do I shade inside the V or outside the V? Well, I'm not going to shade inside the V because y's are little according to our inequality, which tells me everything outside the V should be shaded. All right? What if they give me a pictures and they say, can you write an inequality from that? Sure, not a problem. All right. The first thing that I notice here is this is a unique line. So this particular line is a vertical line. I know that all vertical lines are in the form x equals something. Now in this case, it's going to be x equals -3. However, x equals -3 would be the line. This is an inequality. I know that this inequality is going to be either a greater than or a less than because I have a dashed line. Now, we've been using this concept of y's are big or y's are little. There's no y's in this equation, but we do have an x. So if we have x's, we can use the same concept of big and little to help guide us. In this case, the shaded region is to the right of that line or towards big, which means big means greater than. So I know that my equation here would be x is greater than -3. I'm done. That's it. How about this line right here? Okay, so this line I notice has a y-intercept here at 2. And I notice, let's see, to find the slope, I'm going to use this point. And I know that the slope is rise over run. So I'm going to go up 1, 2, 3, and right 1, 2. Tells me a slope of 3 over 2. That's enough information for me to write the equation of the line. Y equals 3/2 x plus 2. However, this is an inequality. That's the equation just of the line. We have an inequality graph. All right? What region is shaded? Well, remember, here's our big and little. And this graph is shaded in the little region, so I know that means less than. Since the line is solid, I know it's going to be a y is less than or equal to 3/2 x plus 2. All right? How about an absolute value? All right? So absolute value, to graph that or undo the graph, I want to think, where's the vertex? In this particular case, I know that the vertex is at -2, 0. From the parent, I know that this would be y equals the absolute value of x plus 2 plus 0, but we don't really need to write the plus 0. That would be the equation of that absolute value. But we have an inequality. So I go back to my y's are big and little idea. And I notice that the shaded region is little. So that tells me that my inequality for this will be y is less than or equal to absolute of x plus 2. Why did I write a less than or equal to? Because the graph was solid. If the graph had been dashed, I would have just written a less than. Let's take a look at this next one. I have a vertex. Let me go back to the previous one. Why didn't I worry about stretches, compressions, or flips? The reason why I didn't was because from the vertex, I go right 1, up 1, right 2, up 2. It's not being stretched, compressed, or flipped. Similarly, the second graph does the same thing. It goes right 1, up 1, right 2, up 2. It's not being stretched, compressed, or flipped. Okay? All right, so let's do this one. We got the vertex here is at -1, -1. That gives me the equation y equals the absolute of x plus 1 minus 1. So remember, the x value, -1, says left 1. How do we represent left 1? We add 1 inside. All right? It's going to be dashed. And again, I use my concept of big and little. It is shaded in the big region. Big means greater than. So this inequality would be y is greater than x plus 1 minus 1. Absolute of x plus 1 minus 1. And those would be my final graphs, or equations for those graphs. Just one more here. I wanted to show you guys how a stretch might be affected in this too. First thing, if I'm going to do this, notice that they give me this equation, and this is a multiple choice kind of question. The first thing that I do is say, where's the vertex? I know the vertex is at 1, -2. So if the vertex is at 1, -2, that is exactly the same on all three of these graphs. So we're good. Everybody's in place still. The second thing that I'm going to look at here is the inequality. It says Y's are big and solid. That means D's out, B's out. It means that the answer here has to be C. Everybody got it? Pretty simple on how to do that. All right, let me know if you guys have any questions. Go